Find the equation of the line passing through the origin if the angle of reference theta has a sine value of square root 3 over 2. Theta is formed with the line and the positive x-axis. Okay, so because there's no graph given, we're going to have to draw one. Anytime that you have a problem that reference to a figure, make sure you draw it. That way you can visualize it better. So we're going to draw a line passing through the origin, and it's going to also pass through quadrant 1. This is quadrant 1. Here's the angle of reference. It's formed with the positive x-axis and the line. Here's your angle. We're going to draw a right triangle because the sine value function was given. Sine function value. And we are going to label the given sides. So if you have a sine value of square root 3 over 2, it's going to be opposite over hypotenuse. So square root 3 over 2. So those are given. Okay, in order to get the equation of this line, we need 2 points on the line, right? That will be one way to get it. So we have this point, which is 0, 0. So we got that one. So we will need to get the coordinates for this point. And we have one of the coordinates for this point. We have the y coordinate. So we have some x value that we don't know what it is. This is your x value, we don't know what it is. And then we have our y value, which is a square root of 3. Okay. So once you can figure out the angle theta, you can figure it out with the finger trick. Which one has a value of square root 3 over 2? The sine. Sine is the fingers on the left. So square root 3 over 2, if you put that finger down. And that finger is 0, 30, 45, 60. That one is 60. So 60 degrees has a sine value of square root 3 over 2. So we're going to do theta equals 60 degrees. Okay, so now we know that theta equals 60 degrees, and we need to find the value of x in order to be able to get that coordinate for that point of interest, the point on the line. So what trigonometric function connects this length and some other known value? And of course, for the angle theta. So if for the angle theta, this length is adjacent. So if we do cosine of theta, it's going to be adjacent divided by hypotenuse. So we're going to go ahead and do cosine of theta, which is 60 degrees. We figured that part out. Equals adjacent divided by hypotenuse. Okay, cosine of theta is going to be, that's 60 degrees. So cosine is the fingers on the right of the hand, right? Of the left hand. So then we're going to have square root of 1 over 2. So cosine of 60 degrees equals square root of 1 over 2, which is equals to x divided by 2. This proportion is very simple because if you multiply both sides of the equation by 2, then you can cancel out like that, and then square root of 1 is 1. So we have x equals 1. So now we have a coordinate here. This coordinate, this value of x is 1. So we have a point. 1 square root 3. Okay. So we have the point 0, 0, a line passing through the point 0, 0, and the point 1 square root 3. Remember from algebra 1, the slope of the line formula? It was slope of the line equals the change in the y divided by the change in the x. So if you're going to look at the y values from 0 to square root 3, what was the change? Okay, that's square root 3. And then from 0 to 1, what was the change? That's a change of 1. Okay, so the slope of the line equals square root 3. And now you can just form the equation of your line. you have a line, y equals, such that the slope equals the square root of 3, and the y-intercept is 0, because that one was given. Plus 0, so this is in the form y equals mx plus b. So this is actually y equals the square root of 3x. And that will be the answer to problem number 10 on the handout 5.3, problem 10. So square root of 3x.